Alright guys, welcome to this page of the notes and let's start doing some problems. Here we go. The first problem I've got for you is this. A cup of coffee contains 130 milligrams of caffeine. If caffeine is eliminated, metabolized by the body at a rate of 11% per hour, how long will it take for half of this caffeine to be eliminated? Okay, a couple of things about the problem. First of all, after reading it, the first thing that jumps out at me is I am given a percentage. So right away, I know I'm going to need to use either the exponential growth or decay. And which one? Well, it tells me that caffeine's being eliminated. That's decay. So I'm going to need to use that exponential decay formula, which I actually have already given you, right? So here it is. More than likely, I won't give you these formulas and these problems on a quiz or a test. Your teacher probably won't either if you're taking this course somewhere else. But if you're taking it with me, I won't give you the formulas. You'll need to know them. And again, it's not that hard. There's only 4 of them, and you know which one to use based on growth or decay and whether there's a rate or not. So this is the one that we need. Let's go ahead and plug and chug and see what's going on here. All right, so we're going to jump right into this guy, and let's see here. Here's what they tell me. I have a cup of coffee. It contains, all right, so I start with 130 milligrams, and I want to know how long it'll take for, okay, so maybe you remember this problem. We did a problem very similar to this earlier in the chapter. However, the problem we did earlier, I gave you an initial amount of caffeine and then told you I wanted to know after so many hours how much caffeine was still left in your system. This problem's a little different. I've given you the initial amount and then I ask you for the time. How long before half of it is eliminated? So this is a little different. If this one you're like, whoa, this looks familiar. I think we've done this before. Very similar, but a little different. So here we go. I need half of 130, which is going to be, half of 130 should be 65. Yeah, that's what I get, 65 is equal to 130. 1 minus 11% as a decimal is 0.11, and that's going to be raised to the t power. All right, so there we go. I plugged in everything I know, converted my percentage to a decimal. I started with 130 milligrams. That's my initial. My final is half the original amount, 65. I want to know how long is it going to take for the average person eliminating caffeine at a rate of 11% per hour. How long before half of it's been eliminated? All right, so what we're going to do is by dividing both sides by 130. So 65 divided by 130 is equal to 1 minus 0.11 to the t, which means I get 1/2 is equal to 1 minus 0.11 should be 0.89 t. All right, now we've got an interesting thing going on here. So hopefully you remember back in section 6, we talked about the common logarithm, right? The common logarithm, which is a log base 10, which we like the log base 10 for a couple of reasons. First of all, it's very common. It happens a lot. That's why we call it the common logarithm. And second, every calculator has a common logarithm button on it. So here's what we're going to do. We're going to go ahead and use what we learned in section 6 to help us solve for the variable t, which is an exponent. I need to get that t out of the exponent position. I got to get that t by itself. But the t is an exponent, so how do I get it down? Well, we actually did this in section 6. I will take a common log of both sides. Log of 1/2 and log of 0.89t. Now, hopefully what you'll remember from back in section 6 is now that I've taken the log of both sides, because algebra says whatever I do to one side, I got to do to both sides, I have a power property for logarithms, right? My argument is raised to a power. I can use the power property to bring that t out front and multiply it as a coefficient. So what I've done is I've gotten that variable, that t I'm trying to solve for, right, that t, I've gotten it out of the exponent position, and it's now multiplied as t times the natural log, the common log of 0.89. Well, to get the t by itself, divide the log of 0.89 to the other side. T is equal to the common log of 1/2 divided by the common log of 0.89. If you do that in your calculator, again, you've got a common log. Every calculator's got a common log button on it. Do it on your calculator. You will have to round a little bit, but I'm rounding my answer. I get about 5.94 hours. So, metabolizing caffeine at a rate of 11% per hour. If you drink a cup of coffee or something like that that has an average amount of caffeine in of 130 milligrams, it'll take about 6 hours for your body to eliminate half of the caffeine that you drank. Unfortunately, after about 2 or 3 hours, you're starting to feel like taking that second cup or switching to Mountain Dew, even worse. And so you're just constantly running on an enormous amount of caffeine. So please be very, very careful of the caffeine. But anyway, there's a great problem, slightly different variation of something we did earlier in the chapter. Head on over to the next page of the notes. I got another problem for you. I'll meet you there.